We're surrounded by machines, from bikes to cars, but have you ever wondered what makes them tick? Today we'll reveal the 10 core ways machines create and control motion, giving you the ultimate engineering cheat sheet. By the end, you'll spot classic motion systems, predict how they behave, and choose the right one for any job. Ready to unlock the secrets of how things move? Let's get started. All right, let's dive into the fascinating world of mechanical motion and power transmission. We're going to start with a fundamental system that you've probably encountered countless times in your daily life, often without even realizing it. This system is simple, elegant, and incredibly versatile, forming the backbone of countless machines and devices. It's the belt and pulley. At its core, the belt and pulley system consists of two or more wheels, pulleys, that are linked together by a flexible belt. This belt acts as the crucial intermediary, transferring motion and power from one pulley to another. The beauty of this system lies in its simplicity and adaptability. When you turn one pulley, initiating the movement, friction between the pulley's surface and the belt grabs the belt and in turn spins the other pulley. This transfer of rotational motion is the fundamental principle behind the system's operation. This seemingly simple mechanism is surprisingly prevalent. It's the very principle that keeps your car's alternator running, providing the electrical power necessary for all its functions. It's also how a treadmill moves, allowing you to get your workout in, regardless of the weather outside. The belt and pulley system is a workhorse in countless applications. Now, here's where things get interesting. By strategically changing the sizes of the pulleys, you can dramatically alter the speed and torque characteristics of the system. This is a key advantage that makes belt and pulley systems so versatile. What happens when a small pulley is driving a big one? You get more torque, which is rotational force, but at the expense of speed. The larger pulley will turn more slowly, but with greater power. This is ideal for applications where you need to overcome a heavy load. Conversely, what if a big pulley is driving a small one? In this scenario, you gain more speed as the smaller pulley spins much faster, but you sacrifice torque. This configuration is perfect for applications where speed is paramount. Another advantage of belts is that they are reversible. You can turn either side of the belt and the other pulley will faithfully follow, maintaining the direction of rotation. This adds to their flexibility and design. However, belt and pulley systems aren't without their limitations. Their primary weakness is slippage. If the load becomes too high, exceeding the belt's capacity to grip, or if the belt is simply too loose, it will slip on the pulleys, resulting in a loss of power transmission. Interestingly, this slippage can sometimes be a beneficial safety feature. It can protect your motor from damage in the event of an overload or jam. The belt acts as a mechanical fuse, preventing the motor from burning out. Beyond their versatility, belts are also known for being relatively quiet and smooth in operation. They are also well suited for transmitting power over long distances, making them ideal for a wide range of applications. You'll find them in everything from record players, where smooth and consistent speed is crucial for accurate sound reproduction, to various household appliances like washing machines and dryers. However, when it comes to applications demanding extremely precise timing, such as in an internal combustion engine's camshaft, where the precise opening and closing of valves is critical, you need a system that offers significantly more grip and eliminates any possibility of slippage. A timing belt with teeth might be used, but that is approaching our next system. In summary, belt and pulley systems are generally cheap to manufacture and maintain, operate quietly, and offer a degree of safety due to their ability to slip under excessive load. However, they are not the ideal choice for applications that demand the highest levels of precision and accuracy. When your application absolutely requires zero slip and unwavering precision, it's time to consider the next mechanical system in our exploration. So, with a solid understanding of the belt and pulley system under our belts, let's move on to explore other fascinating methods of mechanical power transmission. In the world of power transmission, where efficiency and reliability are paramount, engineers often face the challenge of selecting the right mechanism. When the stakes are high and slippage is simply not an option, what do you turn to? Enter the chain and sprocket. This dynamic duo offers a robust solution for transferring rotational force, ensuring a direct and unwavering connection between driving and driven components. Sprockets have teeth, meticulously crafted to provide a precise interface. These teeth are the key to the chain and sprocket's positive engagement, and chains have links that lock in, fitting snugly between the sprocket's teeth. This interlocking design is what sets them apart from other power transmission methods. No chance of slipping. The positive engagement ensures that every rotation of the driving sprocket translates directly into movement of the chain and, consequently, the driven sprocket. This is critical in applications where precise timing and consistent power delivery are essential. This is why bikes, where every pedal stroke needs to translate into forward motion without loss. Motorcycles relying on immediate throttle response and efficient power transfer to the rear wheel. And chainsaws use them, demanding relentless cutting power without hesitation. Every bit of force goes straight to the wheels or the cutting blade, or whatever needs to be moved with unwavering certainty. The efficiency is undeniable. Change gear ratios by counting sprocket teeth. By varying the number of teeth on the driving and driven sprockets, you can precisely control the speed and torque output of the system. Precision you can trust. This level of control is invaluable in applications requiring fine-tuned performance. Chains are strong and reversible, capable of withstanding significant tensile loads and operating in both directions, but noisier and need regular lubrication to minimize friction and wear, ensuring longevity and optimal performance. They're perfect for when you need strength and accuracy in demanding environments where other systems might falter, like in high-performance engines, where precise valve timing is crucial for maximizing power output. More maintenance than belts, requiring periodic cleaning, lubrication and inspection to maintain peak efficiency, but unbeatable for positive, slip-free power. When every ounce of energy needs to be transferred without loss, chain and sprocket systems reign supreme. Chain and sprocket, the workhorse of mechanical motion, reliably driving countless machines and systems around the world. From bicycles to motorcycles, chainsaws to industrial equipment, the chain and sprocket system continues to prove its worth as a dependable and efficient means of power transmission. But when parts are in close proximity and you need to transfer motion efficiently, there's often a prime candidate for the job. We're talking about a mechanical marvel that has been around for centuries, quietly powering our world. Gears are king. They are the unsung heroes of mechanical engineering, the reliable workhorses that keep everything moving. From the smallest clock to the largest industrial machine, gears are essential. Gears have interlocking teeth precisely engineered to mesh together. This is where the magic happens. The shape and arrangement of these teeth determine how the gears interact and transfer motion. This interlocking design allows for direct, slip-free motion transfer. Unlike belts or chains, gears provide a positive drive, ensuring that every rotation is accurately transmitted. This is crucial in applications where precision is paramount. They reverse direction, spin one clockwise and watch what happens. The next goes counterclockwise. This simple change in direction is fundamental to many mechanical systems, allowing for complex movements and power distribution. Need to keep the direction the same? Add an idler gear to match directions. This clever trick allows you to maintain the original direction of rotation while still transferring power between gears. Speed and torque depend on the number of teeth. This is the core principle behind gear ratios. By changing the number of teeth on the driving and driven gears, you can precisely control the speed and torque output. 10 teeth driving 30? Let's see what that gives us. That's a 3-to-1 reduction. The output speed is reduced by a factor of 3, while the torque is increased by the same amount, minus losses due to friction. Gears come in many types, each designed for a specific purpose. The world of gears is surprisingly diverse, with each type offering unique advantages. There are spur gears for parallel shafts, the simplest and most common type. Helical gears for smoothness, with their angled teeth providing quieter and more efficient operation. And bevel gears for angled shafts, allowing you to transmit power between shafts that are not parallel. They're precise, strong, and essential for complex machines. Think watches, where tiny gears work in perfect harmony to keep time, or car transmissions, where gears are constantly shifting to provide the optimal power and efficiency. Gears cost more, especially when you need high precision and durability, and they need careful alignment and lubrication to minimize friction and wear. But nothing beats them for accuracy and power. When you need reliable and precise power transmission, gears are the way to go. They're the backbone of modern mechanics, quietly enabling countless technologies that we rely on every day. From the simplest hand drill to the most sophisticated robotic arm, gears are there, working tirelessly behind the scenes. Now let's simplify. Friction wheels, two wheels pressed together. Spin one, friction spins the other in the opposite direction. It's like gears, but without teeth. Cheap, easy, and reversible. Used in tape players and simple toys, they're great for light-duty jobs. Speed ratio comes from wheel diameters, just like belts. Downside, they slip easily if overloaded or wet. No good for high torque or precision. Friction wheels are quiet and low cost, but trade reliability for simplicity. Sometimes good enough is the best solution. Meet the worm and worm gear, a true mechanical superpower. A worm, like a screw, turns a gear, giving massive speed reduction and huge torque. For every turn of the worm, the gear moves just one tooth, perfect for lifting heavy loads. The magic, it's self-locking. You can turn the worm to move the gear, but not the other way around. That's why car jacks and guitar tuners use them. No slipping back, not very efficient, but unbeatable for holding loads safely. Worm gears, high torque, irreversible, and safe. 10. Go. Want to turn rotation into straight line motion? Use a rack and pinion. The pinion, a round gear, meshes with the rack, a straight gear. Turn the pinion and the rack slides. It's fully reversible. Push the rack and the pinion spins. Used in car steering and CNC machines for direct responsive control. The distance moved depends on pinion size. Bigger pinion, more movement per turn. No self-locking here. If you let go, the load can move freely. Great for motion conversion, not for holding things in place. 10. Need custom motion? Enter the cam and follower. A cam's special shape turns rotation into programmed up and down movement for the follower. The cam's profile controls the motion, fast, slow, or even pauses. Used in car engines to open valves at precise times, and in sewing machines or music boxes, usually irreversible. The follower can't drive the cam. Perfect for repetitive timed movements from simple rotation. 9. The crank and connecting rod is the heart of piston engines. The crank's off-center pin and connecting rod turn rotation into smooth back and forth piston motion. It's fully reversible. Rotation creates linear motion or vice versa. Found in engines, pumps, and even bicycles. The stroke depends on the crank's design. Longer stroke, more torque, efficient, powerful, and everywhere in engineering. The humble screw is an engineering marvel. Lead screws guide motion in 3D printers and lathes. Turn the screw, the nut moves in a straight line. Some screws are self-locking. Turn to clamp or lift, but loads can't turn them back. That's how car jacks and vices hold with huge force. Pipe wrenches use a self-tightening screw for a powerful grip. Screws offer precise movement or massive clamping, all thanks to their thread design. From guiding to locking, the screw is essential. None of these systems work without guides and constraints. Guides force parts to move in a set path, like train wheels on rails or pistons in cylinders. Bearings let shafts spin but prevent wobble. Designers must choose materials and shapes to handle compression, tension, or shear. Guides are the silent partners, giving machines their structure and precision. Good engineering is as much about controlling motion as creating it. 8. There you have it. 10 core mechanical systems behind almost every machine. Now you can spot, understand, and predict how things move. You've unlocked the language of machines, your new engineering superpower. If you enjoyed this, hit like and subscribe and share your favorite mechanism in the comments. See you in the next build.